Okay, hi guys. So in this lecture, we'll be continuing on seeing more examples on Grignard reagent. Okay, so let's start. We have something like this double bond over here, and we have now x moles of CS3 MgBr. Okay, so obviously we need to determine the value of x, and we have H plus also here. Okay, so we have to determine the value of x such that there is no more option for CS3 MgBr to react after any of the product is formed in any of the intermediate process. Okay, so let's say, so when the x, let's say the x of value is starts from 1. Okay, so x starts, so when we have 1 mole, the first mole will be used in x starts from 1, so the first mole will be used in having something like this Mg plus Br, and we have something like this CS3 would be attached here, and again we have O here and this compound. Now what will happen is, again this will leave and this will form a double bond here, so we'll get something like, or no, this will be leaving, so to have something like this. Okay, now what next will happen is, obviously we can acidify it here itself, so we'll get something like OH. Okay, in the next step we'll be getting something like, when x value starts from 1, when x value now it is also another scope to react one more CS3 MgBr, so we'll leverage that, and we'll have something like, when the second mole actually attacks on this, we will have something like I'm sorry, again it will attack on this carbon atom, we'll get something like O minus Mg plus Br. In the next step, obviously again we have a double bond, and this will be leaving this carbon atom, so we will have something like C double bond O, and I forgot that CS3 was already attached on this carbon atom as well. Okay, so CS3 would be getting attached here, one more CS3 would be getting attached here, so we'll have something like this, and obviously we would have OH and OH here. Okay, now there is one more possibility, because a double bond is there, so CS3 MgBr will take full charge of that, and again it will react. So this is the third mole we are using for the Grignard reagent, and again the CS3 MgBr will again attack on this carbon atom to form O minus Mg plus Br and attach itself also. Again in acidic medium we'll get something like OH, so total x value would be 3. Okay, let's look at another example. We have something like this, plus we are using Br Mg, and this is the R group. It's attached on both the extreme ends with MgBr. So what will happen, we pass it in acidic medium, so what will happen is, again this CH2 will attack on this carbon atom and will form something like O minus, this MgBr will be getting attached here to the O minus, so Mg plus Br, and this CH2 would be 1 2 3 4 1 2 3 4 would be as it is, and we'll get something like CS3 OET here. Now in the second step what will happen is, again this will form a double bond, and it will get this leaving group out of the organic compound, so we'll get something like, again double bond here, CH2 1 2 3 4 and MgBr. Now next what will happen is, again this will actually attack on this carbon atom to form a ring structure, something like 1 2 3 4 5, and we'll get O negative and Mg plus Br here, Mg plus Br here. Okay, now what will happen again is we have no more living group attached in this carbon, in this organic compound. Hence on on passing H plus in acidic medium, we'll get finally this product. This would be our final product. Okay, now let's look at another example. We have something here as a phenyl ring or a benzene ring, and we have these compounds attached here. Okay, now what happens when we react it with CS3 MgBr? Again, this CS3 will attack on, this is in excess, so we need to find the final product. Okay, it will attack on this carbon atom. We'll get something like, again, CO minus Mg plus Br, and we'll get Cl here and CH3 here. Meanwhile, we'll be continue to have OET as well as OET here only. So we'll get something like, again, this will leave the group, and we would have something like Cl will leave the carbon atom, and the double bond will be there between the carbon and oxygen atom, again restored. We'll have something like this. Okay, and similarly, if we repeat this process on repetition, we'll get something like same compound here as well. Okay, now on these two carbon atoms, again, what will happen when CS3 MgBr reacts? Again, we'll get something like this compound, O minus here and O minus here. On in acidic medium, will require 2 moles to finally form the final product as OH here and OH here as well. Okay, so this is the final product which we get. Okay, let's see another example. In this example, suppose we have a compound like this, 2ET here, and we get, so in how many ways this compound can be prepared? So let's take the first approach. In the first approach, we can have something like this plus C2H5 MgBr. It will result in this compound. Second approach, we can have something like this plus CS3 MgBr. Again, it will result in something like this. Third, we can have something like this compound also. We can have something like CS3OET plus again ET MgBr or 2ET MgBr. Yes, and we can also have something like we can have something like this compound. This is directly Cl plus again 2ET MgBr, or we can have ET here and CS3 MgBr, 2 moles of CS3 MgBr. Would it also give the same reaction? Would it also give the same? No, only 2 moles of ET MgBr should be there, because in the original compound to be formed there are 2 ETs. Okay, so these are all the possible ways in which it can be formed. Okay, so we come to the end of this lecture. In the next lecture, we'll be seeing more reactions in which we'll be seeing hydrolysis of nitrile group, C double bond N group, and things like that. So till then, good luck and goodbye.